I'm going to suggest you let me read it, say what I'm going to say, and then you decide what you think is important enough to write down. Because again, it's going to be available later if you want, right? Okay, so the net force, and I've already alluded to this a little bit already, right? So, in the expression F equals ma, see, some of you already read it, you're not listening. Listen first. There'll be a chance. Okay? You have to figure this out, you guys. Really, your best interests are my best interests, right? I'm trying to teach you what you're going to need for next year. Trust me. Been there. In the expression F equals ma, the A can be interpreted as the total resultant acceleration which a body receives when acted upon by some total force whose magnitude and direction are given by F. So Newton's law says F equals ma, the resultant, if I could use that term from vector terminology, the resultant acceleration on the mass is caused by the net force, right? Usually you're introduced to F equals ma, grade 7 or 8, maybe for sure, well, grade 10, I guess, right? And it's very simplistic. Obviously, we're going to get a little bit harder now, a little bit more complex, and so the F is really F net is equal to ma. And some would argue that the acceleration is a net acceleration, although you don't see that too much. So F net equals ma. The F is the net force, right? Some total force. Some total force. So, since force is a vector quantity, the total force acting upon the object is the vector sum of the separate forces that are acting. It is usually called the net force, the vector sum. Now, we've spent some time, we've done it in grade 11, we've talked about vector sum, you know that they should be added tip to tail. We don't worry so much about that in grade 12 because we're going to be using components. Are we going to be using components the rest of our life in here? Grade 12? Absolutely. Okay? So F net is equal to F1 plus F2 plus F3, and then dot, 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 because could be any number of forces. Now, I've called them F1, F2, F3, and so on, but they could be Fn, the normal force, they could be Fw, they could be applied force, they could be friction force, they could be any number of things. So generically, F net is equal to F, the first force plus the second force plus as many forces as there are. As many forces as you can identify from your 3 by 9. Okay, here's an example. I'm really hoping you can just look at this and go, yeah, I don't need to write that down. Again, available later, you can print it out if you really want, right? Johnny and Billy are playing tug-o-war. Each is pulling with 75 newtons. Does it say in opposite directions? It doesn't. But it's tug-of-war, right? You gotta think a little bit. You gotta, okay, yeah, you know? Okay, so the net force, F1 plus F2. Now, does it have to be F1 and F2? Someone might call it FA1, applied force 1. Someone might call this one FA2. I guess you could call it FJ and FB. It doesn't matter. As long as it makes sense to you and that I can interpret what you're saying. Right? 75 is one way, minus 75 the other direction, and so the net force is 0. Now the question is the thing in the middle of the rope moving? Most people have seen a tug-of-war before, and they know that the rope doesn't move, right? But what if Johnny had started out pulling with a greater amount of force, and he got the whole system moving to the right, and then he slackens off a bit and just matches? Then the object would be moving at a constant velocity. Okay? You might remember this in grade 11 too. So the answer to the question, is the object moving, really depends on what it was already doing. And do we know what it was already doing? We don't. So it could be, or it might be at rest. You remember that sort of discussion from grade 11? Kind of, sort of? Okay. Here's another one. This time they're working together, pulling on a sled. Each one's pulling with 75. Each one pulling with 75, they're pulling together. Doesn't come out and say it, but it implies that they're pulling in the same direction. This time the net force is 150. Do you need to write that down? Brian, do you need to write that down? Do you? No? There's really no right or wrong answer. It's what will work for you. Okay, well, let's talk about friction. Basically, I'm taking you through grade 11 physics in about 20 minutes. The key points. In real situations, friction is often a force that reduces the net force. Right? Friction is often a force that reduces the net force. We know that. And results in the formula. Now, is this a new formula? Is this just a reworking of this one? Yeah, right? The net force is the sum of all forces. And so all this one is a rewriting of that, right? The net force is the applied force plus the friction force. Those are the only two forces acting inside of it. So the net force is the applied force plus the friction force. And we use that one sort of so much that we kind of think of it as a formula, but it's really just a rewriting of that F net equals F1 plus F2 kind of stuff. Good, Shan? Yeah? Okay. Now, recall that FF, like all forces, is a vector. So being in the opposite direction, it will have a negative sign associated with it, right? Often students want to write FA minus the friction force. The danger there is that sometimes they get it wrong, and then suddenly they've got a wrong answer, right? So I encourage you to write this. This sign here is actually vector addition, right? And the friction force itself has a negative direction. Okay. Is this an example question? You want to write now? I'll pause. I'll let you write now. Suppose a 10 kilogram object being accelerated by a 10 Newton force. The force of friction is 6 newtons. What is its resultant acceleration? What would be the first step? What would be the first step? Identify the forces, right? You can do this. That's our mass. Accelerated by a 10 Newton force, that would be our applied force. The force of friction is 6 newtons. That would be our FF. What is the resultant acceleration? We are solving for A. Let's draw a picture. Weight force, normal force. Now it doesn't say, right? It doesn't say anything about any vertical forces at all. What does that sort of tell you? Do we need to worry about them? Yeah, right? They're there, but nobody cares. So we know that the mass is 10 kilograms. Sometimes we'll just put the mass inside the box. We got a 10 Newton force applied. I usually draw my applied force to the right, and the force of friction is 6 newtons. So we're going to make it a little bit smaller, FF. What is the resultant acceleration? So I need the A. My last formula is going to be F net equals ma, but I don't have the net force. What is the net force? FA plus FF. The net force is going to be 10 plus minus 6. Let's write it like that. So that it sort of solidifies our understanding there. So the net force is 4 newtons. Notice how, again, and I sort of harped on this about in grade 11, get those equal signs lined up, right? Organize your work a little bit. Think ahead. And it just takes practice on how to do these. So that 4 newtons is my net force over here. So that's going to be 4 equals the mass is 10. I'm solving for A. Okay? They expect you to be able to do this like without even, it's like walking. That's how effortless it has to be. 4 divided by 10, 0.4 meters per second squared. Two-mark question, right? Would you agree that you've seen that in grade 11 before? Renee? No? Apologies to Nick. Okay, this is a good example of how kinematics comes into these questions. All those formulas that we just finished writing a test on. So, a 3 kilogram object going at 5 meters per second at t is equal to 0 seconds. 4 seconds later, it's traveling at 2 meters per second. What force of friction is acting? Fred, are you writing notes on your phone? Because it looks like it. You are? Okay. You'll have to send them to me later, and then I'll have them in phone format. Mm-hmm. So let's write it down, and then we'll identify what these numbers mean. Okay, so let's identify here. A 3 kilogram object, mass is 3, is going 5 meters per second. Is going. What is that? The initial velocity at t is equal to 0 seconds. What is that? At t is equal to 0 seconds. All of this is kind of code for the initial velocity of the interval is 5. Duh, the start of the interval is 0 seconds. We always start with 0 seconds. 4 seconds later, the time elapsed, the delta t is 4. It is traveling at 2 meters per second. What is that? The final velocity. The final velocity of the 4-second interval. What force of friction is acting? What are they asking for? FF. None of these are any forces. None of them. Okay? Don't write this down. Do not write this down. This formula is what I call the bridging formula. It takes you from dynamics, all those force formulas that we're going to encounter, and it allows you to get to kinematics because A will appear in the kinematics equations. Right? You need this one to get all those kinematics ones. So I got to get to here. Once I get to here, then I'm going to solve for my A, and A always leads you into these things. Okay? So I need to get to F net equals MA. Do I have the net force? I do not. Do I have any forces at all? The only one I have is friction. What happens when there's just friction present? Things slow down. Things that are already moving slow down and quite often stop. Is that what seems to be happening here? I think so. I know this from years of experience. You have to work on that experience. So in other words, what is the net force here? If I draw the picture, weight force, normal force, let's draw friction this way. It didn't say anything about any applied forces, therefore, the net force is the friction force. Do you need to write that down in your solution? It's debatable. The net force is the friction force, which is what we're trying to solve for, right? I think I've started backwards, haven't I? That's what we're trying to solve for. I've got to get F net first. From mass, do I know the acceleration? I know the mass. I need the acceleration. This needs to come over here. Good thing I'm using a pencil and I can erase. Okay? How can I get acceleration from VIT and VF from? Yeah? Or the new version of that, which is VF equals VI plus AT. The VF is 2. The initial is 5. We're solving for acceleration, and the time is 4. Okay? Again, you've got to be able to solve these sort of like easy. Right? You got to subtract the 5 first, so it's going to be 2 minus 5 all over 4. 2 minus 5 is minus 3, minus 0.75 meters per second squared. What time am I here till? 11:18? Okay, got 8 minutes. There's my acceleration. Now I'm going to find my net force. I'm going to erase this with my eraser part of my pencil. Minus 0.75. That's 2 minus 5 over 4. Okay, so I'm solving for the net force. The mass is 3. The acceleration is minus 0.75, giving us a net force of 3 times minus 0.75. 1.5 minus 2.25, I think, right?
Why did we say FF is equal to FF?
That's going to be the very last one. I was starting, I think, and then I realized, oh, that's actually the last statement. 3 times minus 0.75? Isn't it? 1.5? That's right, isn't it? Yeah. 3 times 0.75? Yeah. And now I'm going to go, oh, what friction force is acting? Now I'm going to make that statement. But there, F net is FF, and so the friction force is minus 2.25 newtons. A little bit of backwards thinking, really, right? Sometimes you're going to start at a problem and realize, oh, I'm not going anywhere here. I got to start again, or I've actually started at the back and I have to sort of work my way backwards. It takes practice. It's as simple as that. I'm just going to look ahead here. I'm going to do that last one tomorrow. You should have picked up, I'm going to stop talking. You should have picked up, I'm looking for one that has a little separated. You should have picked up this sheet here, that's Darth Vader on the top there, okay? I've decided I'm changing things up a little bit, okay? The pretest thing works good when people are ready for the pretest. The pretest thing doesn't work good, and it's one of my bailouts, so excuse the rant. Okay? They want to go right to the pretest and ask for help. They haven't learned yet, they got to practice. Okay? So I'm going to try this with them, and I'm going to try it with you. You'll notice that I've starred a few questions. Okay? You're not getting the pretest until those 3 are done. Okay? I'm not handing it to you until those 3 are done. You have to show me you've at least practiced 3 questions. Okay? Tomorrow I'll do the last example, and I'll give you some time to work on it. Of course, you